Yep, I see them
Are we
over here.
live? Are we live?
Live. We're live. We're live. Ooh, you even
Nice.
got the sub goal going?
Yeah.
Damn, bro. That's crazy. Yo. Is it live?
I
Like
think
this, it's
so.
like a live feed?
Yeah. I think so.
Really? No
Let
way.
me
No
see.
way, bro.
Oh, you're
Describe.
talking about the sub thing.
Yeah,
Oh,
yeah,
yes,
yeah.
it is live. Yeah.
Oh, really? Oh,
Yeah.
dang, bro. That's nice, dude.
Yeah.
Let's go. Hey, yo,
Let me make sure it sounds
production,
good.
bro. Production is going up. Carlos is going all out in this stuff, dude.
All right.
Damn,
We're
bro.
here. I was just
Hey,
double
we're here.
checking.
Yeah,
We're
yeah. Me too. You
back.
too.
We're back.
Mhm.
We're here. There's no music in the background. That's because I couldn't figure it out before the stream.
Uh huh.
But it takes I'll fix it for next stream. But this is we got a new little setup going on. Nothing crazy, nothing crazy.
Crazy. Yep, yep.
We got some little effects up here or whatever, and then same old
Okay.
background, but we added, let me see if I can point to it.
You go
That
for it.
up
You go for
there,
it.
that's a
It's
live
a what?
sub goal.
Right over here.
So
Yes, sir.
don't worry about how I did it. Don't worry about it. All right?
Just
Just know
process and get
that whenever you
fired.
sub or whenever you unsub, it's gonna be a live feed. Let me test it actually. You know what? I'm
Ooh.
gonna test it right now.
I'll test it up with you. I got you. I got
Okay.
you.
Hi,
Test
hi
it with
Kai.
you.
How's it going?
Hey, welcome, Karaj. Welcome to the stream.
All right. Are you gonna test it out? Who's gonna test it
I
out?
got you. I'll test it out
All
if you
right.
want.
Yeah,
All
it'll
right.
take like 30 seconds to update. That's not on me though. That's on
All right. I'll
Google.
unsubscribe.
All right. Let's see.
Let's see. Let's see. Oh, we'll see. We'll see how fast this thing
Come on,
is.
please don't do me
Couple
dirty.
seconds. Come on, my guy. Come on, my guy.
Let's
Oh,
go.
really? Did it already?
Yeah.
Damn. Well, my stream over here. It's a little bit
Okay.
back. So damn. But hey, I'm gonna trust in your. I'm a. I'm gonna trust in your word, hey, bro. That's
Oh,
crazy,
you'll see it on
dude.
the stream. You'll see it.
All right, bet.
But
Nah, oh
yeah,
yes, I saw it right now, bro. Though that's
yeah.
crazy, bro.
So new
Nice.
sub go up here. Jose, point up.
I got you right here, right here, right here,
Yeah,
right
right
here.
there. We got a new sub goal. So if you want to sub, there it is. There is supposed to be alerts, but
Uh huh.
I honestly forgot about it. So
No worries, yeah, bro.
um, there might
You
be
got
an
a lot.
alert whenever y'all sub. So now it'll say like your name. Maybe. Like I said, maybe.
Maybe.
I don't know. We'll see what
All right.
I have it set up, but we'll see what happens. I haven't checked on it. So anyways, yeah. So this is how
Yes,
the stream
sir.
looks. It might get a little bit better as time goes on, but not a
Working
big increase from the last time. The major thing though is that sub goal right there.
this
So
up, go. Yes,
y'all gonna have fun with
sir.
that.
Hey, little by little, bro. Little by little.
Anyways, any updates, Jose? Any updates or no?
No, my guy, I'm just pretty chill, pretty calm week, right?
Mm-hmm.
Supposedly over here it's supposed to rain a lot,
Yeah.
thunderstorm warnings, the flood, blah blah blah. Like everybody's going crazy, bro. We've got nothing, bro. I mean, it's
You
rain,
got nothing.
but not to the point where like, oh my god, we have to rush home because nah, bro. It's just like drizzles here and
Yeah.
there, like not nothing too serious.
Okay.
So school got canceled. Like the universities here, with the
Uh-huh.
university here canceled schools, summer schools like the high school summer schools,
Uh-huh.
middle school got canceled. Uh, across, because I live in a border city. Across, they also canceled schools, bro. It was just a drizzle, bro, and
Damn.
nothing to. Maybe later on, it's gonna come hard, right? It's just gonna pour a lot of rain.
Yeah.
Right? But for right now, it's pretty chill. Nothing too much. But other
All
than
right,
that,
right.
we're just here. We're just here.
Yeah, same here. Chill week. Actually, on Tuesday, I rolled my ankle playing basketball.
Oh,
Yeah. So, right,
damn.
if I'm not gonna show my foot, but it's very
Yeah,
bruised. It's
really.
extremely
Damn.
bruised. Yeah. So I've been limping,
Career ending?
icing it. No, not career ending, thankfully.
That career ending? Oh,
Um,
that's good. That's good. That's good.
yeah, so it's been pretty rowdy couple days for me, with the
Um,
sprained ankle, if you will. But yeah, um,
did you? Hey, the important thing is, was it because somebody broke your ankles, or you just like stepped
no,
wrong?
no. I immediately started the game. You know, it was gonna be a good game.
Huh?
I haven't played in like a couple
Ooh.
days. I
Huh?
was getting ready, and I guess I was going for a rebound or something, and I just landed on someone's foot, and it
Bro.
instantly went.
Uh,
Yeah.
bro. I get you though.
So
You
it
should do
sounded
the
like a glow stick, like a like
like,
that.
oh, bro.
Yeah,
Oh, nah, dude. I can feel the pain, bro.
yeah. But other
Uh,
than that, chill week. Actually, homework has been pretty chill too, so nothing
yeah.
crazy.
Sure. Yep. Yep. Yep.
Um, that's about it. So enough yapping. Let's
Let's
get
get to
started on
work.
some problems.
Get started with some problems, yes, sir.
All right, let's figure this out. Let's see.
Yeah.
All right, that was another addition. Is the transitions? We got some
Ooh,
transitions
we got
now.
transitions. That's
It's nothing crazy. It's like it's whatever it comes with. So,
yeah. Hey,
um,
something is something.
yeah.
Yes,
But
sir.
that's the transition. Um, I guess here's the problem. So we're
Ooh,
gonna be doing
ooh, I
trees
saw the
today.
transition, bro. That's nice.
Yeah, we're gonna be doing trees, and that's about it. Jose picked these problems. We have two problems. We have this one. Let me get the minimum absolute difference in BST. So we
Mm-hmm.
have these two problems. This one, there you go. So
Yep,
and then
yep.
we might do a third one. You never know.
Maybe,
We'll see
maybe,
what
maybe.
happens depending on how difficult these problems are. But
Sure.
let me make sure something. All right, cool. All right. Without
Yep.
without further ado, let's get started.
Yes, sir.
Problem 110, balanced binary tree. Given a binary tree, determine if it's if it is height balanced. So, for example, one, you have a. Actually, hold on. What is height balance?
Oh,
Okay,
click it
height
right there. Yep,
balance.
yep.
A height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. Hmm. Okay. Okay. So, so for example one, there's two subtrees. There's 9 and then there's 20. There's two different nodes that have subtrees. Is that correct?
Yeah, you can say so. Yeah, yeah.
And based off the two different subtrees, the difference in height of them doesn't exceed more than 1. So 9 has a height of 0 and then 20 has a height of 1. So that's not more than 1. On this one, there's two subtrees. I think this would be counted as a subtree, right? Two or no?
Yeah, yeah,
Okay.
yeah.
So there's two subtrees. The one on the left, one on the right. The height of the one on the right is 0. The height on the one on the left is 1, 2, is 2. Or if you want to count, if you want to do a 1 index, then it's 1, and then this one's a height 3. And then for the example 1, this is 1, and this is height 2. So however you want to do it, but the difference of the height shouldn't exceed more than 1. So in example
Mhm.
2, this one exceeds more than 1 on
Yeah.
this other one. So that's why it returns false. Lastly, if there's nothing there, you just return true.
Sure.
Okay.
Yeah. I don't know. I don't know if you remember AVL trees from data structure.
AVL trees. Okay. Yes.
Yeah.
Yes. I
Yeah.
remember the name. Don't remember what it is. They like
It's the
self
same.
balance, right?
Yeah, exactly. It's the same thing where you have to count the height and check if it's balanced, right? Where you count the left side and the right side, subtract them, and see if they're balanced. You get
Mm-hmm.
me? Yeah. So yeah. And the way I think about it is like each like a line. For example, the line between 1 and 2, that's
Uh,
one. Then there's a line from 2 to 3, that's another one.
okay.
Yeah. So that's how I count them.
Okay.
Yeah. Yes, sir.
So what are you
But
thinking? I have something in mind, but what are you
go for it. Go
thinking?
for it. No, no. I saw this problem and it got me thinking. So I'm interested on you.
Okay.
Yeah.
So if I'm understanding this problem correctly, if a node, the root, has a left and right, we want to find the depth of the left subtree and the right subtree. And then if you subtract the absolute value of those subtree, the heights of the subtrees, and it's greater than 1, you're going to return false.
Yeah.
If it's not greater than 1, you're going to return true.
True. Yeah.
So, what's up, Codes? How you doing, bud?
Michael's
here.
Too.
Oh,
Michael,
what's up, bud?
Come on, bro.
Michael,
yes, sir.
how you doing? I don't even see you
Welcome to
here.
the stream, my guy.
What was I saying? So,
about the height. Yeah.
Okay, yeah. So I know we've done a problem where we find the depth of a tree. How we did it, I kind of forgot, but the way that I thought of, just I didn't think if it's like the best solution or not yet, but is doing the breadth first search and just counting the different layers in the array.
Oh, okay. I see.
The different elements in the array.
Yeah.
That was just the initial idea.
Yeah.
My approaches.
Yeah, of course.
So, yeah, so then you have to check if there's a left, if there's a right before you do the breadth first search algorithms on those subtrees. But that's what I was thinking.
I see. Okay.
Codes. Hey, we've been streaming for I don't know how many weeks straight.
I think it's been like 7 weeks straight.
Dude, it's been more. Sure. There's no way.
Really?
How many streams do we have? I think we have like 15 or something.
Let me check that up. I got you.
But we haven't stopped, Codes. We found a way to stream once every week. That doesn't mean it's the same day every week. It just means we stream once every week. So, we've been grinding, man. And I think me and Jose, well, I don't know. Jose said he was going to start doing it, but I was telling Jose that I've been doing like a problem a day. So, we're grinding, Codes.
We're grinding here, my guy. We're grinding here. You know, this is what it's about. And just for the fact we have 17 streams.
17 streams.
Which means 17 weeks.
17 weeks. How long is 17 weeks?
That's four
like
4
months.
Like 5 months, give or take.
Wow.
5 months.
Yeah.
We've done this consistently.
Yeah.
Yes, sir. We're growing and we're growing. Little by little, we're growing. Hey, that's a plan, Coach. That's a plan.
Shoot. If Fang is there, Fang is there. If Fang ain't there, that's okay.
Yeah. Sir.
All right.
All right, let's get this.
So what was I saying? Oh yeah. So that was my approach. So what about you?
Yep. Let's see. I was thinking of doing. We have to traverse the tree. That's a thing, sure. Right? Yep. For sure. Well, how are we gonna traverse? So we can give. Ooh. I'm not sure. We can do. No, not an in order. In order, that's not gonna work. I don't feel like it. Because we need to figure out a way, like, to decide where to go. You get me?
What do you mean?
Like, for example, on 1, right?
Mm-hmm.
On example, on 3, example 1, right? We go to 20, or example 2, over here, right? We go to 2, right? And then we go to 3. No, on the left side. Yeah, 2. Okay. Then we go to 3. Yeah, but then we also have to go back to 2 and go to the other 3. You get me? Then we have to check 4, and then we have to go back to 4 and check 4. You get me?
Yeah.
So we have to like know a way, like where to go and see if we hit a leaf, call it like that. So we can do. Okay, I see. I'm trying to think in here. So we go 1, 2, 3, 4. right? Bro, this is a difficult one.
You think
This one
so?
is um
I mean,
maybe
I
I'm
was
just
saying the
overcomplicating.
BFS. I was saying
Yeah.
BFS. If there's a node on the left, do BFS. If there's a node on the right, do BFS. If there's
Ooh.
none, then don't do it. Then return true. That means it's a single root, and that would be true, I think.
Okay, let's try it. Let's try it that way. Yeah,
Okay. Do you know what I'm saying though?
yeah. Not quite.
Like for example two,
Hmm?
you're starting off the root. Obviously, we're saying if there's
Okay.
a left node. There's a left node. That means that's the left subtree. If there's a right node, that's the right subtree.
Mm-hmm.
We're gonna run breadth first search on this to get the height. So it's gonna put 2 in its own array, and it's gonna put 3 in its own array. You know how the algorithm works, right?
Yeah.
We've
Uh-huh.
done it. So then you're gonna have 3 different arrays in a bigger array, and you just count the length of that array, and that would be height 3. 1, 2, 3. And then you do that for the right subtree, and it's gonna return 1 because there's only one in there.
All right,
Then
so we're gonna run the thing two times
you're gonna run it twice, yeah.
for the left and for the right.
Yeah. And then you're gonna get the length of the
Of
arrays
the
on both
Okay, okay,
sides,
I see. I see, I see,
the
I see, I
absolute
see. I
values
get you.
of it, and then subtract them. If
Yeah.
it's greater than
Yep, yep.
1, then you return
Yeah.
false.
Yep. I get you, I get you. Okay. I see, I see, I see, I see, I see.
Something like that.
Yeah, I like that, I like that.
Okay. So
Yeah,
write
yeah,
pseudocode.
yeah, for sure.
Okay.
Yeah.
So
I think we should create it as a function though, like the
yeah.
BFS, so we can
Mhm.
like reuse it again, so we won't have to like type. Yeah.
Yeah.
So it's gonna be DFS create function DFS. Do you have it memorized? No.
Uh
All right. So
possibly,
I got it's
possibly.
hey, we're gonna use the tip that one of our subscribers gave us on the Discord. If you're not in the Discord, make sure to hit the link down below. You know, where we share tips, where we learn. It's a community where we learn, you can learn, everybody learns. It's fun. We have debates, we have things, we have like little struggles of like we should do this, we should do that. But hey, it's all fun and games, right? The point there is to learn. One of our subscribers said to do the DQ,
Oh.
because list, right?
Yeah.
I don't know if you want me to explain this, but
Explain it.
I'm a.
Let me say what code said real quick before you go.
All right, bet.
I wish you the best of luck. Try to land an internship with them if possible. I heard they're more willing to extend full-time offers to previous interns. They got the right mindset. We appreciate that, Codes.
We appreciate codes. Appreciate it.
You know what? That's the goal then. That's the
That's the
goal
goal.
to get an internship and then do good in our career. So, and Ali, hello, how's it going?
Ali, welcome to the stream. Welcome to the stream.
All right, Jose, whenever you're ready, explain it. Explain what the viewer said in our Discord that
Okay,
we
I got
didn't
you.
know we're doing it wrong this whole time.
I got you.
Go.
So in list, right, in Python, there's something called list. This list works similar to stack, but can be used as queues, right? So lists are more similar to stack because they work like a stack, but they're not technically a stack, right? But there's a function called pop, right, where you can set it, use pop 0, and make the list function as a queue as well. The problem with this is that a list, as I said, works like a stack. So imagine a stack of plates where we have a stack of plates, right? And we pop 0, right? Because we're trying to use it as a queue, so we want to pop the first one that got in. The list, what is it going to do? It's going to loop all the way through the stack, all the way to the bottom, which is to the bottom plate, right? Which is the first plate that got in there, and it's going to pop it, right? The problem with that is that it's O. This thing is O of n, right?
Yep.
It has a complexity of O n since it has to go through each of the elements on the stack to go to the very first one, the very bottom one, to pop it, right? Because we're trying to simulate a queue. So in a stack, the first one that goes into the stack is the very bottom, right? Therefore, we had to use something called DQ from the class I think it's collections in Python, where this stack of plates, right, gets turned over horizontally into an actual cube where we can do pop, and it will immediately pop it from the left, from the very first item that got in there, without trying to look through all the other plates, which means that this algorithm is O of 1, which is constant time, which is better, way better in O of n. So this post was given us by one of our users in Discord. If you want to check the full comment that he gave us, right, check it down there. Go to Discord, and where he explains the similar analogy with the stack of plates and everything, where you can, learn more from it, right, and ask him more questions if you guys like, and if he wants to respond as well. But yes, so the thing is that with list pop at 0, it's O of n, right, and DQ top left, I think that's the function, it's O of 1. So that's just the difference of which one is which, and that's why it's preferably to use DQ for Q, since it's faster, it's more efficient. So yeah.
That was beautifully said. Beautifully said, Jose.
Thank you, brother. Thank you, my guy. Thank you.
Yeah, so, it slipped through it.
It slipped through it. We
didn't think about it.
We didn't think of it.
And that's because with Python, like, you just use the function, but sometimes it goes over our head on how that function really works. So we didn't think that the pop function did all of that.
Yeah.
So nor did we care, I guess. We just wanted to solve the problem.
We just wanted to solve the problem.
Now we care. Yeah. And I don't know if y'all know. What's up, Orcus? I don't know if y'all know. But now whenever you solve it, it tells you the complexities now.
Tab. Yep.
But of course, you got to be a premium member in order to get a lot of uses of it. Like, they give you a max of three uses of it or something like that. Before you could, like, be a premium, or I don't know, some subscription stuff. So, anyways, sorry, that was a side note. So now they tell us what the complexity is, which I don't know why that hasn't been. I mean, obviously, I know it's good for us to calculate it ourselves, but that's what we're gonna keep doing. But I just thought it was interesting that they added that, and I feel like that should have been added like a long time ago. Or why did they add it now? Anyways, it's a whole different thing. So, Orcus, what's up? And then Michael said, shooting for Fang is overrated. Fang offers aren't as high as they used to be. I'm not in Fang, but my bro is a G. Just become a valuable engineer. That's most important. Absolutely. I think the most important thing is just being good at engineering, at problem solving. And the stuff will come with it. So I agree with that mindset. That we just try to focus on becoming as good as we can, and if we get into Fang, or if we get into another company that we really enjoy what they're doing and their message, then that's all that matters to me, at least. I don't know how Jose feels, but I value like the work that you're doing. Like, is it helping people? Are you making things easier for people? Or like, what are you doing? So that's what kind of gets me up in the morning is doing stuff that has impact. So all depends on what company offers that to me. Anyways, those complexities are garbage. I wouldn't know. I'm not as good as finding complexities yet. Told me that event solution was login for LeetCode. Okay. Oh, now I know that they're garbage, so we won't pay attention to those
maybe it's just guessing or something.
And maybe we won't get premium anymore after that. After hearing that, why would I need premium? They're gonna give me trash complexity. I don't know what I'm saying. Anyways,
and code is just one more comment.
What's up?
Code is given a really good comment. It's more about grinding for a goal and setting the bar high for yourself in personal growth. I agree with that too, my guy. I think if life is a bow and arrow, the higher you aim, the further the arrow goes. Right?
What if wind takes the arrow even further?
The idea. Well, that's why you have to like stretch the thing real back or real strong, right? and like launch the arrow, right? It might not go where you want to go, right? Maybe you're aiming really, really, really far, right? But it would take you further than aiming right close, right? So it's just, just shoot an arrow, aim high, just go with it, my guy. And sorry, my guy. Sorry to interrupt.
No, you're
It's
not
just,
interrupting. It's cool. I like chatting with
sir.
the people. John, what's up? Or John, welcome back. Welcome back. Okay, where were we? Where were we? So you
All right.
explained that we're
DQ.
gonna okay, we already explained our solution or what we think the solution is or the approach we're gonna take. So we're gonna write some pseudocode. Jose was explaining that our old algorithm that we use for BFS, we gotta tweak it just a little bit, and then we're gonna get like a really good algorithm for BFS. Um, Jose, you could read that if you want.
Oh, then shoot for quants and hedge funds. They pay like 50. Damn. Hey, good to know. Good to know. Yes, sir. All right, let's get cooking right here. Make it full screen right there. All right. So we go to left subtree and then go to BFS function there. Then go to the right subtree. Do BF. Okay. Yes, sir.
Calculate.
Difference.
All right.
Yes, sir. All right. First things first. Go to line number 1.
Oh,
Do
line number
import
1.
DQ from collections.
Okay. Or is it import from collections DQ or no?
Oh, no, I think it's DQ, but it's
import collection. What is it?
No, import. Yeah, but without the last UE. I think it's just DQ. DQ.
Oh,
Yeah, like that.
Yeah, sidetrack.
Sure. No worries.
Okay.
All right, then we'll do the yes sir. Let's do it like that. We're gonna do root.
And then we're gonna return an array or no?
Yeah.
Or
yeah.
It's a queue. We're doing the queue way. So is there? You still do that, right?
Yeah. Because we're gonna return a list of answers. So we're gonna do ans equal, I think set.
DQ.
DQ. No.
Oh.
No, that's a queue. So ans is gonna hold the levels, the different levels we have.
Okay.
Then we're gonna do q equals DQ parentheses. There we go. Yeah. Like that.
Okay.
All right. So we're gonna check the root. If it exists, we add it to the queue. Huh?
I thought if root is none, return that.
Yep. And then we're gonna do add it to the queue.
But it's not using a pen anymore, right? We gotta.
No. It's a queue.append. I think so.
Oh, really?
Yeah. Queue. Yeah.
Is it the same stuff?
Yeah, and level over here, level 0. Yes, sir. Right. Yeah, bro, we still got it, bro.
We still got. Hey, my memory is not coming back because it's a little bit different. So, but don't worry, I'm here.
All right, but then we're gonna do DQ. Yes, sir. Then we're gonna pop it. Yes, sir. We're gonna queue that.
Pop left.
Pop left. Yes, sir. And then from there,
thing. Okay.
We're gonna do if length of ans is less than or equal
level
to level. Yeah, we're gonna do ans.append an array.
Bang.
Yep. Bang. Then ans.level will equal that. Oh, yes, sir.
We're getting it. Wait. And then if no dot left, then we're gonna do
q.append. Oh, look at you, bro! Look at you with the
no
and level plus one.
Level plus one.
Yep. Oh, that's beautiful, bro. It's making me feel some way, my boy.
And then
we return ants. Yes,
Something like
sir.
that, right? Something like that. Something
No,
like
I
that.
think that's perfect, bro. I think that's perfect. Not like, bro. I think that's perfect. All
Dude,
right.
I've written this ever since that one stream. I've written this algorithm like maybe maybe I don't know if y'all are expecting like a big number, but probably like 15 times.
Oof.
I
Oof.
don't. I made it sound like I was gonna say like 100 times, but I think
100
probably
times
like
finished.
15 times.
And 15 times still quite a lot. Not lie.
Yeah.
Still quite a lot.
So maybe there is something missing, but we'll find out.
All right,
Okay.
so we got ants. Um,
I'm a little skeptical on this right here. I don't know if it's the right function, but
it is because pop left
mhm.
because the queue, right? It's like if you pop left, they're popping from the left side
No,
of
I'm
the
just
queue.
saying if not the right word of it, like how it,
Oh, okay.
like maybe it's like I don't know. I'm just skeptical that we're
I think it's
missing the.
let me check it out. Let me
Okay.
check it real fast. Yeah. Uh, Give me 1 second, my guy. Uh, DQ. Yeah, because I think you're right. Or I'm not
Michael, if
sure.
you're still here, how you doing, man?
Yeah,
How's
it's DQ.pop left. Yeah.
okay?
Okay.
How's the week been? How you been? Oh, okay. So now we call. Oh,
Call that.
okay.
Okay. Okay.
If
First, we need to get the list somewhere. So we're gonna do list left. We go to BFS DFS root dot left. Uh-huh.
well, I was gonna say we need to check to see if there's a root dot left or root dot right.
Oh, that's true. That's true. That's
So
true. Go
if
for it. Go for it.
what happens if there? How do we say if there's a left but there's not a right?
Or, or,
Or
yeah. What
but
do you mean? If there's a left, there's a.
I'm
Mhm.
trying to think. Like okay, let's say there's no right node. That means we return false. If there's not another node left, we return false, right? That would make it to where there's only one tree. There's no. Oh, there's only.
Yeah, I mean, you can
Oh.
check root dot left. If root dot left doesn't exist, just return false
Okay.
or return. We'll just check if root left call the function, right?
Give me a second. And
I
then,
think it's balanced, no? If there's
well, right here, that there's
uh
nothing. Oh, return
yeah,
true.
right, yeah.
My bad, my bad.
No worries, no worries.
Now
Yep.
here is where we see if root dot left. Oh wait, if there's no root dot left or root dot right, return false.
Uh, I
Left
mean,
is
I will,
none or root dot right is none. False question mark? What are you thinking?
I mean, I don't. I mean, I think that works, but I think there's a better way to do it, though.
Like
Because
what are
you're
you
checking
thinking?
if there's because you're checking if there's a left. That means that we just have the head, right? If you like, let's say one, right? You just have one. On example two, you just have one, no two, nor two. You just have one. You get me? So you can do as say like something at the end of it, the very end. You
Mm-hmm.
can say return true, right? And the if statements, you can say if root left, call the function. If root right, call the function, right? But if none of them pass, just return true,
Okay.
right?
Guide
You
me.
get me? If that
Guide me.
makes it's if root dot left, and then you're gonna call the function. Uh huh. Yeah. Uh huh. Then another if statement, if root dot right, then you're gonna call the function. Yeah. Then if nothing happens, just return true, like no if statement or anything. return true at the end. Yeah, and then on line 49 you can do you can check the sizes of the array. Yeah, yep. Uh-huh. Uh-huh. Perfect. Yeah.
Yay or nay,
Perfect.
yay or nay.
I don't think you need the abs on both of things. You can just like do the subtraction and get the abs of the subtraction.
That is true.
Yeah. Yeah, no, keep that one. Yeah. And then delete. Yeah, right there. Uh, that works. Yes, sir. Let's see.
So let's say there is a left.
Mhm.
You get a height of 5. And let's say there's no root on the right. That means list R is not
It
going to be a
doesn't
thing.
exist. Ooh, okay, I see. Mhm. I mean, you can do an else on a statement else. List T L we equal empty array, or list R we equal empty array. You get me?
Yeah. Is there a better way?
Maybe it's because your way was checking if there wasn't a left or a right, right, or a right. Okay, I see where you're coming. Yeah. I misread you. Ooh,
No,
okay.
I just suggested that, but I didn't think it all through. That was just the first like intuition. So I don't even know if that's the right way. So I'm not even saying like the way that I thought was right. I'm just thinking right now on how we would do it. Like if it's like this, how uh if root dot left, if there's none, then that means because yeah, you could put like oh then that means it's none, or you could write list dot left on the outside. You can initialize it as something and then but or you can initialize it to none, I think. List R equals none. And then if one is none, then that means there's not a subtree because that means I didn't get overridden by this. Right? So that could be a way. But I
Yeah.
was wondering if is there better ways? Is there
Okay, I see.
you have a root, you're checking if there's a left. If there's only a left, that means you're going to return false. Or is it because it's a balanced a binary? No, a binary tree can only be one. Could be one way, right?
Binary
That's
tree?
possible. Yeah, that it could be just all on the left side.
Yeah.
So that's a possibility. So that's when it's going to return false if it's everything's on the left side.
We can add another if statement, right? We can add your if statement that I told you to remove because I thought I'll write it wrong. I misunderstood like the if statement, right? But now I think about it, I think we do need it to solve the problem, right? So we can have three if statements, or we want to keep. I feel like if we want to keep it cleaner, just initialize list L list R, and yeah.
So we would say if left
If root,
node
if
and
root
right node are
yeah,
none, return
uh,
true.
false.
Well, that
Does
means
that
it's just a root.
ooh, ooh. Mm, no, because here is the thing, right? We have a root, but we cannot have like a right side
Uh
tree,
huh.
right? We can
Oh
just have
yeah.
one or
Uh
two.
huh.
right? We also have to think about the fact that what if we just have 1, 2, right? And we just have two nodes, one, and then that node is the left child of two is the left child of one, right? So
Like that.
yeah, like that, right? If we do have that if statement, that means that this is balanced, by the way, because it's 1 minus 0, so it's just 1, right? And we would return false in that case.
Okay.
Gabby?
So if there's no left or right, you return false.
Mm, it's because in that case of the 1 and 2 in case 4, I think that's balanced, no?
You got me there. Uh, I mean, we're
Because
not checking to see if it's balanced. We're checking to see if it's height balance.
yeah, if it's height balance, I mean it's the difference of 1. So here on 1, 2
Those are
is
considered two
1.
subtrees.
Uh, I mean, yeah, it has
That's the
1.
root, though. Root is not even a subtree. Yay or nay?
No, no, it's not a subtree, but it it is not a subtree. But the tree itself is we're checking if it's balanced. If I'm not mistaken.
We're checking if it's height balanced.
Um, but this one does have a subtree.
So
So would it be?
this one's only has one subtree. Is
Yeah,
that correct? So that
yeah.
means we should return false based off this, saying the depth of two subtrees of
But
every node.
the depth of the other subtree is 0 because there's no subtree.
I would think if there's no subtree that it would be just you don't even know there's anything there.
All right, but let's do that. Let's do that.
But
Let's see.
I could be totally wrong. I don't know.
Yeah, but let's do your way. Your way. Let's see. Because I
Okay.
might be wrong. Because you do have a point. Because what if would it be like would that be considered to have two subtrees? You get me? But
Yeah.
let's see. Yeah, let's check.
How'd you want to do it?
Yeah, let's go.
If left.
To your if statement. Yeah,
Okay.
if left no or equals is none. I
Does
think
this
it's
work?
or. I think or would be better. Because what if you wait a minute? Because that means that you only have the head. Wait. No, you're right. You're right. Yes. You're right.
No, now you got me thinking. You got me thinking, man.
I think it's or. If you want to do what you like, if because here on 1 and 2 that would be true, I think, or or it would be false. But to according to that if statement, it wouldn't hit that if statement. So I think it's or. Like if we don't have a left or we don't have a right, return false. That's where this case for is gonna become false.
Okay, so now let's say we don't have any, and these go through.
What do you mean any?
Like, look. Let's say we do the or, right? And let's say left is not none, right is none. So that means you're gonna do what?
Return false. Yeah.
Now what if um hmm
Yeah.
okay. Wait a minute.
You get me?
You might be onto something. Yeah.
Because that was your original if statement with the or. Because the end would mean that we just have the head. We just have the just the one.
So that means
That means
if
we don't
both
have
if
the
there's
left.
both something, then we're gonna do this. Okay.
Exactly.
Okay.
Yeah. I think
Now
so.
the
Yeah.
question is, does this count as
Balanced?
like yeah, would this will this need to be returned true or not? That's like what you. Oh, no.
Let's run it. Let's run it. Let's run
Sorry,
it.
you want to run it?
Yeah. Because we're actually gonna get if it the output for 4.
All right. Line
I think I
one.
did it wrong. Did I? Let me see.
I think it's this one.
Yeah, from collection. Yeah. You were right. You were right. My bad.
Okay.
Ooh.
Let me move this.
Check 4. What's the output for 4? What does it have to be?
True. You little mother.
It
Okay, so it is. That
is,
theory
man.
was correct. Is that
Yeah.
if there's nothing on the right, or does root count as a subtree?
The root one doesn't count as subtree. It's a tree because right. I want to check the depth of my right. In this case, right. I don't have nothing there, so it's 0. I have a depth of 0, meaning that you're on top, right. If I go left, I have a depth of 1, so you get 1 minus 0, you get 1. If that makes sense.
So are you saying? Hold on. I never respond to Mike real quick. I'm sorry, Mike.
Yeah. I
I
did.
just saw it.
I've seen it. I saw it for a
Mike
couple.
said, "You're
Great
chilling.
weekend.
You're chilling. You had a good holiday on Wednesday. Yep, me too. Barbecue on the beach with friends. Ooh, baby,
Oh, he's
barbecue.
been out,
Dude,
bro.
that sounds like a good
He's been
time.
chilling, bro.
That sounds
He's
like a
been
great
chilling
time. Plus the
on the
sunset.
beach. On the
I
beach.
I assume you like sunsets,
The
just like
vibe.
your profile picture. I would assume you're a sunset enthusiast. But
Ooh,
correct me if I'm wrong. You can't complain. Oh yeah, I wouldn't complain either. And then how are the hardworking geniuses doing? We're doing good. Other
doing
than my
amazing.
foot, it's kind of purple right now. I sprained my ankle, or I rolled it playing basketball on Tuesday. So
Don't remind me about my
I've been
ankle, bro.
icing it. Yeah, I've
What
been icing
is it?
it. But other than that, I've been doing good. Doing good. This weekend I'm planning on going to the lake, so to celebrate. Yeah.
Hey,
What?
yesterday. It was
Hey.
yesterday, bro.
Nah, I'm not, I don't really show it off like that.
All right, but fair enough,
But
fair enough, fair enough. No,
if you
no,
want to do it, I
no,
don't
no, no,
say it, but other
no, it's
people
okay.
could say it for me.
Nah, it's alright, brother. It's alright.
Okay.
It's alright. I respect it, of course.
Yeah. I don't
All right.
mind. I was just saying, like, I don't really say it, like, I
Nah.
don't post it either. Like, I don't
Yeah. Me,
care.
I'm not that kind of guy
But
too.
people could post me, like
I
that.
get you. I get
You
you.
know what I'm saying?
Yeah. I get you. I get
Like
you.
people could post me and be like, "Oh yeah, make sure to wish them or whatever." So,
Yeah.
but like, I'm not gonna do that. That's for sure.
All right, but I get you. I get you. I get you.
Anyways,
All right.
yeah, I had a
All
good
right.
day yesterday. Gonna celebrate this Saturday.
Yes,
That's about it.
sir.
Okay, sorry. Let's
Let's
get
get
back
this
into
one.
it.
All right.
So,
So I think we have to delete that is for 44 to 45. I think so, baby.
44 to 45. That's what you're
Yo.
thinking?
Yeah, the if statement 44 to 45.
Oh, I'm sorry.
Yeah, right there.
Okay.
Then
Oh, then this is gonna be 0. List.r is gonna be equal to 0.
yeah, or you can define them on top and just be
Yeah.
like empty
Yeah.
list.
Oh,
Right.
empty list.
Yeah, I would say so. No, so that way we have a length of 0.
Yeah. You're a genius.
Ah, but no. We work together. We work
You're a
together.
genius, dude.
No. We work together. We work together. We're teamwork.
So
Alrighty.
then, okay.
All right. Uh, what happened on case 1 though? Because
Output is false. 1, 2.
1 minus 2, that's 2. Should work. So it got false here in this statement.
Let's see.
Print here.
What?
Oh, but
Anyways, that was weird.
okay, okay.
Why? What?
um,
The
um,
other thing we had was if root dot left, root dot right is
equal
none.
nine.
I don't think that would have messed this one up. What?
Ooh.
I'm confused.
that's
I don't
that's weird.
know. There's always something. Maybe we just don't see it.
Do
But
you want to check it first to see if we like who always wrong with like that if statement?
oh, okay. So you want me to?
Yeah, let's see. Just for curiosity, because that is weird.
Oh, oh, no. If root, or maybe because it's worded wrong. Let me see. I don't know if that changes anything, but oh, nice.
Oh, it did pass. Okay.
So just the way it was worded.
Oh, I think because it's you said root left, right? Root left or so if there exists root left, right? Because root left is just checking. We get it root left,
Uh huh.
and if there's something root left, return false. It's not adding like root left or is not. You get
Ah,
me? There is not just affects a root right. Oh, okay.
yeah,
Okay.
that makes
Good to know.
sense.
Good to know. For sure.
So,
All right.
uh,
Whoa.
okay. I believe all we did was just
Yeah. Hey guys, share the stream. Share the stream. Because if
hey,
people subscribe, you see this content here,
oh
it's gonna
yeah,
go up. It's gonna go up.
yeah. If y'all didn't know, this little sub goal is responsive. Is that? Can I use that word
Yeah,
correctly?
I think so.
It's
Yeah.
responsive. So if you sub or unsub, you will see it go down, or you'll
Yeah.
see it go up. So just
Yep.
FYI, just check it out if you want to check it out. And also, if you sub, there might be an alert that comes up, but I'm not 100% sure, so don't quote me on that. Anyways, I think we just solved this problem.
I think we solved the problem.
Do
I
you
thought it
want
was
to
gonna
check
be
to see if
harder.
there's? Whoa! Don't get too ahead of yourself.
No, I thought it was harder. No, I thought it was harder. Like,
Let's see if there's any test
ooh,
cases.
okay. Yep.
Uh, this guy seems to have some issues. Let's see. Okay, what else? Anything else? Do this one. Is this the same one as that one? 4, no,
Yeah.
no, 4. Yep. Why is this
Oh,
true?
no,
Okay, they're having issues with this one. Is this the hardest easy question someone asked?
Ooh, look at. Okay. Okay. Hey, put the link of the channel, bro.
Okay, test it.
Yep, let's see.
Oh, I'm pissed.
Ooh. I think there was a comment there why this was false. Will you
No.
get it?
Okay, I
I
got
don't
you.
know if you want to read it.
Yeah, I
No,
got you. I
we
got
don't
you.
have to read it. We don't have to
Okay,
read
no.
it.
I don't want to read it then.
Uh,
Oh! Okay. So, doesn't it tell you how it looks like? Okay. Uh, so this needs to be true, right? Oh, false.
yeah,
Okay.
it's false.
What? Why? 1, 2, 3. 1, 2, 3.
Of every node. of every node. That's the
We're
keyword.
cooked.
Of every node. So we have to check each node if it's balanced. Of every node.
What do you mean by that?
Like 2 has to be balanced, 3 has to be balanced, 4 has to be balanced, not just 1.
Oh, I'm cooked.
For example, 2 is not balanced because it has 2 on the left and 0. So 2 minus 0 is 2, which is greater than 1. Therefore, it is unbalanced.
Oh, I'm cooked.
Damn, bro. Damn.
We were like getting ready to submit. You said, I thought this was gonna be harder.
Boom,
They just pulled the rug from under us.
Bro, reverse card on us, bro. What?
Okay. So does that mean we gotta do recursion? Not like change the whole thing, but I think simply just
I was thinking
right here we have the function.
we have the PFS.
Yeah. We just gotta do it for each
So,
node.
I was thinking,
What are you thinking?
what if we put everything in a loop?
Okay.
And we just loop through each node. And if we get a false, we break and we return a false. Else we return a true. I don't know if that makes sense. It's gonna be a horrible solution, but I think it might work. So we go to 1, we go to 2, we go to 3, we go to 4, and then we go to 3, we go to 2, we go to 3, we go to 4.
Height balance binary tree is a binary tree in which the depth of 2 subtrees of every node differs by more than 1. Never differs by more than 1. The depth of 2 subtrees of every node. Okay, I see.
So we have to go to 2, check there, go to 3, check there, go to 4, check there. See.
I see.
Yep.
I don't think it's quite over yet.
Yeah, me neither.
I think it's possible.
Mm-hmm.
It's just
Chat, if you guys have some tips or tricks on how to solve this.
Wait.
Uh-huh.
So does that mean whenever we go to node 2,
Uh-huh.
we're checking its left and right nodes?
Uh-huh.
But we're going all the way down to 4 still, and then when we go to 3, we're checking its left and right.
And if 2 has a right child, we have to go to that right child, check if it's
check all its left and right nodes.
All of its left, all of its right nodes, if they're balanced of every node.
Do you want to just do like
I was thinking
pre-order traversal and just run the function on every node?
I was thinking the same thing where we go to each node, right?
Yeah.
And we figure out how figure out the height of each tree, right? And if we get false in there, we stop the loop and we just return false.
Okay. So how about this? So clearly we need this sort of check each time we're in the node.
Yeah.
So
that's
do we make this whole thing a function?
No.
Okay.
The BFS is good. Just this from 44 down, because that's where we check each left or right node.
Oh, okay, yeah. So we're doing DFS now.
Yeah. We can do in order traversal, or we can go to each node. If root is none, return. If root
left. equals root dot left, something like that, or no?
No, we
No,
as soon as
you call it
we,
again.
yeah, DFS on root dot left. Yeah. Wait. Oh, which one are we doing? DFS, in order, pre-order, or post-order?
Whichever one you want. We don't matter.
Let's do in order. We
Okay, so that
go.
means it's in the middle.
Yeah. Right there.
Then
Right
we're gonna call
there.
we're gonna call BFS on the root. No.
No, I think we're gonna call this, no? All the 53 to 65.
You're gonna call it, and then you're gonna have this code.
Yeah.
How do we do it over here?
Wait. Let's see this. Let's think about it.
Like this.
Oh no,
Like that.
that's.
Something like that. No, I don't know, dude. I don't know. Think about it.
Think about it. So we're gonna go
Each
left.
node.
We go there. We
Okay.
check. All right. So let's do case 5 for example, right?
Okay.
We're here. Yeah. We go 1. We
Let
check.
me move this
right?
over.
Ooh, nice.
All right, case 5.
Right. Case 5, right? We check if there exists the root, which is 1. It's perfect. We go DFS.
Okay.
We send the root.
Yep.
Right.
Root
Then
is
we
none.
do root is none. Right. It is not none. So we continue. We do DFS.left. So we go to the left. All right. So we're gonna go all the way left to 4.
Yep.
Right. And then 4. Then DFS.left is gonna return false. Then we popped out. And then we send the BFS. We send 4 to BFS. Right.
Yes.
And we check, right? We check everything there, blah, 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 blah. Then we do DFS right. That doesn't work. We bounce back. Now we're at 3, right? 3 is the left one. So we're going to do the BFS thing. Boom, 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 boom. And then we're going to go right. Since right doesn't exist anything, we pop back to root dot left. And this time is 2. Yeah? You get it?
We're gonna return true
On 2?
on 4.
Yes, we're going to return
Okay.
true. Yeah.
Now we're on
True.
3.
Now we're in 3. We do the BFS, right? Here we're gonna return true, then do DFS
On BFS,
right.
we're not gonna return true.
On BFS,
On number 3.
yes, we're gonna return true.
Oh, because it's only 1.
Yeah,
Okay.
exactly.
You can go to 2.
And then we go to 2, right? We pop back to root dot left. We do there. That's where we're gonna return false, right? So we need to figure out if we get a false thing, right?
Mm-hmm.
False. A little false thing, we have to return false, right? And then after that, we pop back up to 1 and we check right. And now we go all the way again to right. Right, right, we go to 2. 2, we go to left. Wait. No way. Do we have to do it 2 times?
What?
Because it's gonna go root dot left, right? We're gonna go 2 all the way to 4. 4 goes to left. No, we check 4. Go to 2. We go to 2. Problem. Okay. No. We good. No worries. No, I don't think we need it 2 times. I think we're good there.
Okay.
Yeah, I think this should work. We just have to figure out a way to, if the returns false, we exit out the loop or out the function. Yeah.
So you're saying right as soon as it hits false,
We exit out because now we know that not every node is balanced.
But it's recursion.
Exactly. So we need to figure out a way to return false.
You got to do pre-order then.
I don't think it matters which ones you do.
Because if you do in order, you're going all the way down to 4. And if you're returning false, you got to go all the way back up to at least the root where you started.
That is true. That is true. That is true.
And if you do pre-order, you're starting at 1, you go to 2.
But also that affects too if there is like 2 has a child on the right. You get me? You have to loop through all the way to 4, right? And then go all the way to 2, and then go to the child of 2. So either way,
it doesn't matter.
I think so, right?
But how do you stop a recursion?
Recursion. So okay, so when you return false, you wherever you get the false, right? For example, let's say 2, right? This case, 2 is going to return false. That false is going to get sent
all the way
to the root.left call.
Yeah.
That's where we're going to check if. So each DFS, right? Every time we call DFS is going to have
the condition.
Value.
Okay.
Yeah, we're going to do if DFS true, right? Or I think you can do it like that. Call a function. Yeah, because it has a return statement, so I think it should be possible. So if DFS returns a false, if DFS equals false, right? Or right there in condition, right? We check if it's true, right? Return true. If it's false, return false. So that thing is gonna get sent all the way back, right, to the 1, where it has gonna do where it has a return statement itself, right? Where it's root.left, it's gonna check. All right, 2 is false, so this return false, and that's gonna stop the loop entirely. You get me? So you don't have to call condition equals BFS root again. You just have to call it once.
Okay.
Yeah.
And then?
Let's see, right on line 49, I think. Right there. You can do if DFS is false, right? Return true. Return false. Return false. And that should be good. And then on the other one over here on line 68.
What happens if it's true?
If it's true, it's not gonna work, right? So in here it's gonna go all the way to the bottom until it hits the next return statement, which is true at the very end. You get me? So it checks, all right, hey, DFS left isn't true, right? It's not DFS, right? We're gonna do the DFS, we're gonna go there. Dot left 2 is gonna recur to dot left, right? And then let's say it returns true, right? It returns true. Well, we don't do anything, right? So we do 1, right? 1 is it? I think so. Yeah, if we do 1, it goes through the BFS, right? It returns true per se, right? Wait, let me think about it. Maybe I'm thinking it wrong. Oof.
You pissed me off.
Me? Why? Why? But what am I doing?
I'm just joking.
What?
I'm just joking.
Nah, you good. So because I get confused with the recursion. Because we go to 4, top left doesn't go, we go to 4. Then if that thing returns, okay, so we have a return statement that's false. That returns over here. Okay, so that's a dot left of left. If it returns false, we go back. 3. Okay, yes. So on 2, right? 2 is gonna return false, right? Right there.
Yep.
2, and it's gonna hit line 49. It's gonna hit this statement. 49 is return false, and then 1 is gonna return false, right? But let's say 1 is true, 2 is true, right? 1 is gonna go through the BFS, now, and the BFS is gonna go all the way through, right? And it's gonna return. Oh, here's gonna be the problem.
What's the problem?
I think because here at 1, it's gonna go to 1, right? And it's gonna check if it's balanced, and if it is balanced, it's gonna return true. Get me?
I'm thinking.
What do you think? I'm rambling. I'm rambling right now.
Okay.
I don't give you your space.
Take a step back.
Yeah, let's take a step back. I'm gonna let you go. What's your idea?
I think the idea is that once it hits false, we needed to send that all the way back up and break, and so it doesn't go to the right.
Yeah.
So in order for us to see that, is
I think
right
line
here.
49 does that. Yeah.
But like you said, it's gonna keep going to the right.
No, it's gonna do 1. No, it's because right here, if it's 49, right, 2, right, it's gonna return false, right? So it's gonna pop out, right? You get me? Well, let's say 2 is true, right? We're now gonna do 1, and when it's a 1, it's gonna return true. The entire function is gonna return true. You get me?
I say that we have it to where okay, I got it. I'm thinking that's a little ugly. That's a little ugly. Hear me out. I'm just gonna write it. It could be wrong. Hear me out though.
Yeah, go for it.
Dot self dot bool equals. I mean, what? Yeah, whatever. Okay. Wait. Self dot bool equals true. Okay. Once, if this is false, if condition bool, no, condition, this is gonna return either true or false, right?
I don't think so. I think that returns a list. Huh?
Oh yeah,
The
it does return
BFS,
list. Yeah, it does return list. Let me see.
or is it DFS?
No, you're right. What did I have it? Return true. Can we have the BFS? Can we create this as a function?
If you want, yeah, we can do that.
Because then that means it would do it automatically. You got to pass in root and then.
Yep.
Okay, let's see. So, what do you want to call it?
Let's call it balanced.
It's going to be all of this, right? Like that?
Uh-huh.
So, we call balance input the root, right? Or no?
Uh-huh. Yep.
And we're going to call this condition. Just hear me out. Then root dot right here. Just gonna move that. Then we're gonna say If it ever equals false, self.bool equals. This might be like ugly, but hear me out. Hear me out.
Yep. Yep.
So then it's gonna run through everything.
Yep.
It's gonna run through all the nodes. It's not gonna stop whenever it hits a false. But we will know that it hit a false because
I get you. I get you. Yeah. I see.
self.bool.
That works. I felt. Yeah. I think that works. I think that works.
I don't know if it works, but that's just what I thought of.
I think it works. Yeah. Yeah, because you're checking if it's false. If we ever get like a false thing, yeah, I think that works. I'm pretty sure that works. Yeah. Damn, a lot of functions. Whew.
What is this right here? Did we still need
to
that?
check if we, yeah, because that check if it's empty or not. If the entire tree is empty.
Okay.
Yeah.
Did you have any doubts?
I had one, but no, it's soft. You thought about it. Yeah.
Okay. Do you want to try it?
Yeah, let's go for it. Yeah. Oh, you're a genius, bro. Let's go. Let's go.
No way. No way, right?
I think so, bro. I think so.
No way, right?
Run it or submit it, bro. Submit
No,
it, bro.
no.
No. Come on, bro. Submit it, bro. Submit it, bro.
Okay, hold on.
Submit it, bro. Nah, bro. Look at me. Look at me, bro.
I'm looking.
Look at me, bro. Submit it, bro.
All right.
Submit it, bro.
Ready?
Submit it. Yes. Let's go. Go, bro. And live is for the ones that challenge. Go for it.
Submitting.
Let's go. Let's go. Let's go.
All the way at the bottom, baby. We'll take that.
There.
We'll take that.
There.
Oh, man. Oh, man. That's right. We beat 5%. That's
go.
What we're talking about.
Let's go.
I need to screenshot that.
At the bottom, maybe, but we in here. We are in here.
I'm gonna use this for a thumbnail. All right, ignore that.
Yeah, you do you.
Okay, I'm gonna use that for a thumbnail.
We in here.
Let's analyze the complexity.
Oh, bro.
Let's see how false this is. It is
O of N.
Okay.
That's understandable. It is understandable.
Is that true?
Yeah,
because we are looping. Or not?
I think helpful? It's thumbs up. I think it's a thumbs up because we're looping through each node. I think so, no?
Shoot, you're asking the wrong guy. Thank you, Michael. Thank you. I'm glad you were here to see the success.
Thank you, my guy. Thank you. But I think it's O of N because we're looping through each node. So let's say we're given a binary of n nodes. We're gonna loop through all those n nodes and check that stuff.
Wow. Do you want to explain it?
Nah.
Okay. I guess I'll explain it.
No. I was thinking not to explain it.
I was just thinking for like the YouTube video.
Oh, okay. No, if you want to explain, I'll explain it if you want, because you read the question and you were typing stuff. It's only fair.
So you want to explain it?
Yes.
You could get very general, by the way. You just say like, this is the BFS algorithm. The only difference we did was the DQ, and then you just say the balance. This was the conditions we were gonna check. Blah blah blah, and then talk about the DFS, whatever. So you don't have to go too crazy, because I know it took a while, but make it as general as possible. You got it.
All right, but yes. No, just to keep the tradition, whoever codes, and leads a problem. The other one, yes, sir. All right, so this problem we were given the 110 balanced binary tree. So what does it mean for a tree to be balanced? Well, for every node, its depth of its subtrees, left and right, has to have a difference of no more than 1. Which this means, for example, in 1, right, we go to node 9. Since we don't have both, since 9 doesn't have subtrees, it returns 0, right? Since 0 minus 0 is 0, so that's balanced. We go to 15, 0, 0 equals 0, right? Since balanced, it has no childs. 7, 0, 0 has no children, so it's 0. Now we go to 20. Here, we get 20. We have 2 children, left and right, so that means it has a depth of 1 on the left and 1 on the right. If we subtract them, we get 0, meaning fitting the condition of being balanced, so 20 is balanced. Now we go to 3. We have a depth of 1 on the left and 2 on the right. We subtract 1 and 2, we get 1, so this fits the condition of being balanced. In order to do this, we did a BFS or what is it? Level order traversal. There, thank you. Level order traversal where we loop through all of them. Right, we loop through the left side of a subtree or a subtree. We get its children. We put them in an array. We count the length of the array. Right, well, this is a BFS where we go to loop through the left. We create an array, and we put them in an array. Right. This is the first function. The second function, balance, here's where we pass in the left child and the right child, or the left or right subtrees, into the BFS, right? Where then we get the array, right? And we check the. Oh wait, let me do the. Then we get the length of each of the subtrees, and we subtract it. If the difference is more, right, we return false. If it's more than 1, we return false. If it's less, we return true. Then we go to the third function, DFS. This DFS, right, checks, we traverse through each node, all right, of the subtree. Because if we go to the height balance definition over here on the left, right, it says that we have to check the balance of each node of the tree. So to do this, we loop through all of them doing pre-order traversal, right? Where then we check the balance of each node. After that, we subtract them, and then we have a boolean where we keep track of the balance, right? And if that at the end that boolean is false, we return false. Else, we return true if it's balanced. Yeah. All right. So my explanation was a little bit weird.
I think that was brilliant.
Yeah.
I think you're brilliant. Don't worry about it. It makes it more authentic.
Makes it all right.
Yeah. We're grinding.
We're grinding.
You know, there could be an environment behind it. It could be raining behind me. I'm still gonna be here streaming, doing LeetCode.
Yes, sir. Yes, sir.
You explained it right. I'm interested to see now what the solutions that other people had, because that was ridiculous. Look at that.
That was ridiculous. Damn.
Let's see. Let's go to this one.
So, okay, let's see.
Okay.
Oh, bro, this is gonna take us like another hour to like dissect and understand. Oof.
Yeah. Do you want to just exit out of that one?
Go to solutions. Maybe in solutions, right there. Go to Python 3. Maybe it says easy solution, very easy solution, 100%. Blah blah. Oh, okay, my God. Oh, okay.
Okay.
Height. What?
No, I don't know. Honestly,
I don't know. Yeah, me neither.
Nah.
I don't. Yeah. Damn.
Hey, we solved it.
We solved it. That's the thing.
It's over then. So it says.
Over then.
So we solved it. Michael said it's definitely not an easy level. So let's just say we solved medium. This was a medium.
Yeah, medium, easy, hard. It was one of the hard ones, like those to transition.
Yeah. So,
yes, sir.
All right, we explained it. I think that was the first problem. Woo! We got the first problem. Let's go. We respect the game. Levels. Let's go change the insane levels. All right, that was the first problem. It's already been an hour and 20-something minutes. So, you know, after every problem, we change the level, see where we're at. Where are you at, man? How are you feeling?
I'm at a 6, bro. I'm a
You
6
got
or
a
7.
6. Okay.
Yeah, this one it was tough. It was it was hard.
Let me change that for you.
I used my brain power there. I squeezed my brain.
I'm gonna say, dude, I'm gonna be honest. I don't feel that bad.
Really?
Yeah,
Alrighty.
I'm gonna be honest with you
Hey, no
because I
worries, no worries.
knew I knew that we're gonna do BFS, right?
Mm-hmm.
What got me
Was
was the
the pre-order?
recursion
Yeah.
a little bit. So that took me to like a 4. So
All right. All
I'm
right.
at a 4. Let's see it.
Whew.
All right, we're both at 4s.
Whew.
Oh wait, no, you're
No,
at a
mine was
6.
6. Yep. Yep. Yep.
No way. Hold up. Is this? Does it change both of ours? Oh man, I haven't
No.
messed up. I guess I copied it. So I guess I'm at a 6 with you then.
No, 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 no. It's okay, my guy. It's okay.
I don't know how to. I would change it, but we're streaming, so I'll
Okay.
wait.
No worries. No worries. You good. You
Okay.
good. You good. You wanna move on
Now
to
we're here. We're here.
next
What is
one?
this one?
All
What's
right.
the
This one.
rating? 58. Okay, a little bit better.
Okay. This one. All right. Do you want me to read it?
You can read it, man. You can read it.
So this problem is 530. Minimum absolute difference in PST. Given the root of a binary search tree, return the minimum absolute difference between the values of any two different nodes in the tree. For example, 1, right? The difference between the absolute difference is 1. Why? Because we have 2 and 3. You subtract them is 1. The absolute of 1 or -1 is 1. So that's where we get 1. Then on example 2, we have another one because we got 48 minus 49, which gives us 1. The absolute value of 1 minus 1 is 1. So yeah, we just have to get that absolute value.
Okay. Let me try to understand the problem again.
Yeah, for sure, for sure. You go for it, go for it.
So you're given a root of a BST. Return the minimum absolute difference between the values of any two nodes in a tree. Return the minimum. Okay, okay.
Yeah.
So, huh?
It's
How would?
it's
How the heck? The minimum difference.
uh-huh.
Wow.
But I chose some big problems today, bro.
Yeah. Did you?
I
Um.
did, bro. I was like, I'm gonna squeeze your brain. Squeeze all the brain
Hey,
juice.
Jose, pick up your mic.
Yo, yo, yo. Yo, yo.
Yeah, your mic's not on your headset.
Oh, really? Damn,
Yeah.
what the heck? I thought it was in my headset.
It's all good. It's
Yeah,
all
all right.
good.
I get. I'll leave it
Just
there. I'll
want to
leave
let
it
you
there.
know.
All right,
Okay.
bet, bet.
I didn't know if you were muting your mic or not. I was like, I saw you
Yeah.
move it, but then I still heard stuff. So I was like, oh, so I just want to let you know. There's no
Yeah,
mute.
hello, hello. All right,
There we
I think
go.
I changed it, but thank you,
All
thank
right,
you.
got you.
Appreciate it, appreciate it. All righty, let's see, let's
Um.
see.
So let me think. So what are you thinking? I literally have no idea.
Me neither, me neither. Cause
It's brute force, right? Like, is there another way that's not brute force?
I don't think so. I don't think so.
Like
Cause
there's a way where you could get all the nodes, sort them in an array, and then
we
do
could
it
do
from
that.
there.
We could do that. We could do that. I feel like that'd be the easiest way. Like for sure.
Yeah.
Yeah.
Let me see what the topics are. Depth first search, breadth first search, tree, binary search, binary tree.
Yes, sir.
Or is it because it's a binary search tree that we know that it's gonna be on the left side, or we know, or no, you don't know.
That's the thing. Don't know.
So if it's 0 on the left, that means there's gonna be no more nodes on the left.
No more nodes on the left. Well, I don't know. Maybe check the constraints. Oh yeah. No, because we don't have negatives.
So, could you assume? Hold up. Wait a minute. Did we just? Did we lose a
Uh huh.
sub?
Huh?
I think we lost a sub.
I think so too. It
I'm
was it
pissed.
264, no?
I thought I was at 64.
Yo, come on, guys, don't unsub. I mean, you subbed already. Like, come on.
That's funny.
Wow,
Oh, that's funny.
For now, I'm gonna be paying attention to the sub count.
I was like, man, I like this sub count. I looked at it. I was like, wait a minute. Is that
263.
one less?
Nah, dude.
Oh,
We
okay.
become more aware.
I'm focused. I mean, yeah, just do a traversal and then put it into an array and then sort it if you want, and then
I'm down with that.
go to the middle or whatever, right? You go into the middle
We could go to the middle, yeah.
and then get the minimum of the middle two.
Yeah. Ooh, that's actually pretty smart. Didn't think about it like that.
Yay or nay? Yay or nay?
Yay.
All right. That
Yeah.
just seems weird, though.
Right.
Is that what you want to do?
Yeah. Or
Okay,
yes.
Okay, do your thing. What's up?
I was thinking we could do an in order traversal.
Okay.
Yeah, because I think this one works. We're
Wait
gonna
a
do
minute.
left, node, right. Then we're gonna go node, right. You get me?
No, I did a problem. Hold up. We brought it back. I did a
Okay.
problem, and it involved. I wanted to sort after I got the traversal order, but since it's a binary tree, it's already gonna be in order for a certain traversal method. I think it's in order.
Exactly. In
So
order.
it would already be
Exactly.
in order.
It already be in order.
So then
We just do it in order
Hold
traversal.
up.
Put all the nodes in a list.
No, can we
Get
do
them
it
in.
without the list now? Hold up. Now I'm wondering. Can we do it
Ooh.
without the list? Because it's in order. So we're going to say, we're going to check each node to its next node. Wait. Let's just do the in order first. We'll figure it out.
Yeah.
Okay, so we're going to do in order DFS and then maybe do array and check or do in place. All right. So def DFS
Notebook.
DFS root if root is none return and then DFS root dot left DFS root dot right and then in order
be
print root dot val and then all right, see what we get. 1, 2, 3, 4, 5, 6. Okay.
Yes. Yep.
Okay. We're on to something.
We're on something.
Now, obviously, we could put it in an array. Is there a way we could do it without it?
I'm thinking. maybe we can return the value because the mm,
Because what's the minimum number we could get? Is it 1
it is
or
one.
is it
Yeah.
0?
Uh.
Or there can't be two of the same, right?
Yeah. I don't think they can be two the same.
Of any two different nodes in the tree.
I don't think they could be the same. I don't think they'll put something like that.
Is a BST, can there be two of the same or no?
I don't think so. I don't think so.
Okay. So in that case, at the very least, we're gonna get 1 as the
Yeah.
difference, as the minimum difference.
That could be a base case. Mm.
So if we hit 1,
We return immediately.
then return immediately.
Yeah.
If not, then you keep a counter of the minimum thing and then you
Yeah.
return that.
I was thinking the same thing. Yeah. Yeah. Yeah.
Like an outside count?
I think so. Yeah. Like
Or
the Boolean you did on the previous problem.
or will we have to return, will we have to just do the whole recursion anyways?
Yeah.
So then just have a count outside.
Yep. Ooh. This is tough. This is tough.
Equals 1, right? That's the base? Wait.
I would say 0. No, because min. Ooh.
The number of trees in the number of nodes in a tree will, that lowest will be 2. So the minimum will be 1. Yay or nay?
Because what if it's because we have those two nodes have to be in the tree. So maybe the absolute minimum is not 1 but 2. Do you get me? Because there's no two numbers that give you 1.
But the test cases they give out a 1.
Yeah, because here we have 2 minus 1,
Oh,
1,
okay.
2 minus 3,
Oh, you're
1.
saying it could be
Right?
like 4 and 6, and then
Four,
that's
4 and
2.
6. Yeah. Uh-huh.
Okay, so then can I just put?
Yeah, -1.
Well, we just need to
No.
initialize it. So what do you initialize it with?
Can't you just initialize it like that? Or
No.
oh damn. Ooh. That's a
I mean,
tough
there's
one.
always a minimum.
Mm-hmm.
It doesn't matter what we put because it's always going to change. Because we're going to run there's always going to be a minimum.
Okay, okay, okay. Yeah, yeah.
So even if the minimum is going to, if there's only 2 nodes and the minimum that those 2 nodes give is 2, this will still change because we're going to still go through the whole thing.
Okay.
So
Yeah,
we
yeah,
just
let's
need to
go, let's go.
initialize it with whatever. Right?
Alright, bet.
Okay. So then here is where we put our magic.
Mm-hmm.
But
Our logic. Let's see. Minus.
I don't know, dude.
It's a tough one. It's a tough one.
I don't know. Because you're going to say 1
Because we're gonna go to
1 minus the next one, which is 2. But how do you? You're still
I
going to
was
go through everything. You
yeah.
just put it in an array.
Now the issue I was looking at is like this thing is gonna go all the way to 1, right?
Yeah.
We have to return to 2 somehow.
Yeah.
Oh, dude. this is gonna be tough because
What do you mean?
what if 4, right? Let's say, for example, because it says any 2 nodes,
Yeah.
like any 2 nodes. What if one node is one side of the tree and the other one's on the other side of the tree?
Well, it's not because it's in order, and it's a binary search tree. The
That is
minimum
true.
is always gonna be right next to that person.
Ooh, okay. Okay, I get you.
I
Okay,
think.
yeah.
I
Never mind. Never
think.
mind. No, you got it. You got it.
At least when you put in an array, it's gonna be next to them. Maybe on a tree, it's gonna depending on how the tree looks. Maybe
Yeah, yeah, yeah,
it's on the other subtree.
yeah.
I think let's just throw it in an array.
All right. All right. Let's do it in an
Yeah.
array.
Do you do it like this or
You
wait,
can
wait.
just append.
So dude, I'm gonna play that game whenever we're done streaming. It's
You
gonna be fun.
excited?
Yeah. I've been playing Factorial too.
Factorial. Which one is that one?
That's the factory
It's
one?
oh yes, yes,
Yeah.
yeah.
Dude,
Yeah, I remember.
I've
Sounds
been
familiar.
playing it, yeah. Oh!
Oh my god.
Oh! I hurt my foot again. Sorry.
Oh,
I bent
you
it on
good, big guy?
accident. Okay, let's see where are we at. Okay, there you go.
Uh huh.
Now,
Okay, we have to get the middle, which is 3.
yep.
Oh,
Or do you just iterate it from the beginning?
no, because now, no, we have to go to the middle, right? What do you mean iterate from the beginning?
Like just start from the first 2 and then
Uh huh.
shift it over one more, shift it over one more.
Oh, I see. I see.
I mean, you could like
Yeah, I think that works. I think
if
that
the
works.
size is uneven, so 1, 2, 3, 4, 5, you gotta check the left and you gotta check the right, and which one's the minimum of that. If it's even, let's say that it's the size is 3 and you divide it by 2, you're gonna be at 3. You gotta get the one 0, 1, 2, 3. You gotta get the one before that.
Yeah.
Subtract it. I think let's do it in the middle. I think.
Okay, let's do it in the
Because
middle. Let's see.
okay, so if length dot self dot ands
Divided by 2.
2 equals 0, which means it's even,
Mhm.
then that means, or is that an extra step? Can I just do a divide by 2?
I think you can do divide by 2.
Okay, then we'll do num equals length self dot ands divide by 2.
Mm-hmm.
If no, nah, that's still the same thing.
No, you just go to 2. No?
What do you mean?
Like you just go at the middle and check left and right, up and down. And let's say we're uneven, we still check the one before and the one after. No?
If it's even, let's see. Let's say
Like
you
1,
had
2, 4,
1,
6.
2, 3, 4, 5, 6. Let's say there was a 7 and it's even. It's gonna give you 3. 0, 1, 2, 3, you're gonna go to 4. And
Mm-hmm.
then you gotta check the one behind it. If it's
Mm-hmm.
odd, like this, you're gonna be given it's what is it? 5 divided by 2. Then you're gonna be given 2, right?
Yeah.
Yeah or nay?
Um.
It goes down to 2.
Yes. Yeah.
So you're given 2, then you gotta check left and right. So we should have a way to where we see if it's odd, then we do left or right. If it's even, then we just do behind.
I get you. Oof. All right, let's do that one. Let's do that. Yeah.
Let me see. If lane ands modulo 2 is even, then that means.
Give me
What's
1 second.
up?
I'll be back.
Okay.
Give me 1 second. Yes, sir. I'll be back. Give me
Then
1
that
second.
means we return ands. Wait a minute. Ands lane ands divided by 2 minus.
All right, I'm back.
What's up?
Alrighty.
Minus 1. Else
Damn.
return.
What's the -1 for? For the
the
to
one
move back?
previous? Yeah.
I think that one goes inside the brackets.
Oh, I didn't see that.
You think so?
But
No.
I didn't see
Yeah,
that.
no worries. Nah, you good.
And then
Oh.
if it's odd, another if statement, or
I think you could just do the back one, no?
if it's odd, you gotta check 3 minus 2. Or you gotta check
Oh,
3 minus
yes.
2. Oh, okay.
Yes.
Okay. I get it. I got it. I think. Let's say
So
1 equals length ands divided by 2. Wait.
I think you can copy
Ands.
paste the return, the one from above. No?
Yeah.
And you just like I think it's just the
And then
only
you
difference
add
that
one
were the
on the other one.
subtract. Yeah, just the subtracting one. Uh huh.
If 1
And I think
greater than 2.
or you can do return max 1, 2.
You're brilliant. You're brilliant.
There you go. Okay, let's see if this one works.
Ands.
Oh, it's self-dot ends. Sir. Ooh. Bro, please, bro, let this work, bro. I'm gonna be honest with you, bro. My brain is fried.
You think
Well,
so?
it's not fried, but it's like getting there. Yeah. Yep, right there, yes, sir.
Let's see.
Oh,
So floor.
yeah, fluorite. Ooh.
Does this work? Does this work?
Maybe.
Does that work?
I don't know what this does.
Yep. I'll put it 1-1. What the?
Oh,
What
I
happened?
see. You see, because here in example 2 is reading 1, 12, 48, 48, 49, right? And it's going to the middle, which is 12, and it's checking 12 minus 11, which is 11, or 12 minus 48, right? So since 11 is less than the subtraction of 12 and 48 is returning 11.
Oh.
But in
yeah.
here, that's yeah.
Okay, so that means we
Oof.
gotta do the 2 at a time. Is that correct?
2 at a time.
Like you start from the beginning,
Yeah,
you do 2
I
at a
think
time.
so. Yep.
All right. Just as
So
quick
here-
as that, you just erase everything. All the work we did on that. All right.
Okay.
You gotta take over on that one.
And this for loop.
Mm-hmm.
Okay, I got you. So for here, you're gonna do for I in range of length of ends. But this length you're gonna do. Ooh. Okay. So can you do I plus? No, it's not gonna work. Because we need I to start in front of the other one. Let's see.
You could do.
There you go. I like that.
I think so. Let's see.
Yeah.
Print.
I. So fast. Yeah, so fast. There we go. Yeah. Two, three, four. Oh, because I think it's the minus. Okay. 2, 3, 4, 5. Yeah. 2, 3, 4. Wait a minute. No. 2, 3, 4, 6. No. Yeah. I think it's doing it right.
Yeah.
Yeah. So here you're gonna do. You're gonna have a variable outside called min. Min. Yeah. Minimum, which is gonna equal to, let's say, call it Oh damn! This is gonna be what number?
You can put it to whatever. And that's always gonna switch, right? There's always
Yeah,
gonna
but
be
we
a
have.
min. It's
Okay.
gonna
Yeah, I
change.
get you. Yep. Yeah.
Okay.
So we're gonna do. It's gonna do
Minimum.
minimum will equal. No, here's the thing, because if we do minimum dot equal on each iteration, minimum is gonna keep changing.
Oh yeah. Oh,
We have
so
to create a
if
condition.
okay. So
That's
you
what.
do if you do the minimum thing. If minimum.
Uh-huh.
Oh, that's why this matters.
Yeah, that's what that matters, because you can say if minimum less than the subtraction, because serious obviously is less gonna be less.
Huh.
Let's say minimum equal -1.
Okay.
And we're gonna do 2 if statements. So the first, it's a minimum will equal self ends I minus 1 minus self ends I.
Can you do it the other way around?
Yeah.
That. Okay.
And say if minimum is less than. Ooh. Okay. Yeah. Okay. Yeah. We can do that. If count is greater than minimum, set minimum to count.
But that we run into the same issue that you mentioned.
No, because every positive is bigger than -1.
Yeah, but
so now
it's still.
Yeah,
so let's say the count is gonna be 3 now. Let's say it's gonna be 3. Count 3 is greater than the minimum, which would be 1.
Oh yeah.
Then it changes it
Oh,
to 3.
that is true. That's true.
I
Well,
say
check. If minimum is negative, if minimum is
Yeah.
less than 0, if minimum is less than 0, no,
Let me see this
you
real
can.
quick.
If you want, okay, yeah.
Then
I think it's gonna do the same thing, no?
if this like that.
Okay, let's see. If count says a minimum or minimum, yeah, that works.
Okay.
Then we're gonna return minimum. Yep,
Think so?
I think so. Let's run it. Bro, please. Okay.
Let's look for some test cases.
You,
You saw that?
okay. Which one?
The comment or no?
No.
It said easy my.
Yes. That's us,
funny.
bro.
That's funny.
Oh, we got some errors right there.
Alright.
Right there. On year new 2018. Or that one too. Put it in there. Put it in there.
What?
Ah.
Case 4. 4, no. Okay. Oh,
Okay.
yeah, I'll just ignore that. Why is there showing YouTube videos? I need 10 we need 10 reputation to downvote.
10
We
reputation.
need our viewers to get on that, man. What is that? Alright, let's see.
Bro. I hate binary problems, dude. There.
Alright, dude, I think you know what, I'm not gonna say it. We
Let's run it.
passed
Let's
two
run it.
other ones. Running!
Ah.
Hey!
Let's go. Let's go.
Hey!
Let's go.
Hey!
Let's
Hey!
go. Let's go.
Hey!
Let's go. Hey. Hey.
Good
Let's
stuff.
go. Good stuff, my guy. Good stuff.
Oh my
Damn.
gosh.
Oh, bro. I think I'm gonna die, bro.
Dude. Oh, I'm so glad we got that one.
Oh, bro.
Nice.
Oh my god.
That's
Nice.
brilliant.
I like this one. This one is nice. This one was nice.
That's brilliant.
Yes, sir. All
What are you
right.
thinking?
I like it. Let's explain it first.
Okay.
Yeah. You want to do this one?
I can explain it.
All right. Bet.
Let me sit up for this one. All right. To explain our solution, I need to explain the problem again. It's a minimum absolute difference in BST. That means that out of all the nodes in this tree, in example 1, what's the minimum difference you would get between two nodes? So you could literally brute force everything and see all the differences you get. You got to get the least amount difference, which would be 1. And it could be from 1 to 2, it could be from 2 to 3, it could be 4 to 3. It doesn't matter, the minimum difference is 1. Same for this one. The difference between 1 and 0 is 1. 48 and 49 is 1. The difference between 12 and 48, I don't know what it is, 36? 36?
Yes.
That's obviously not the minimum difference, so the minimum difference is 1. That's the basic description of the solution of the problem. What we decided to do was do DFS in order. So we did in order because since it's a binary search tree, you're going to get the sorted version of the tree since it's binary search. So let's say you put it in an array, which we do, you're going to get 1, 2, 3, 4, 6, if that's all the nodes that are in there. You're not gonna get 42136 or 42. Yeah, you're not gonna do that because it's in order. So that means you're gonna get 1, 2, 3, and then 4, 6. So it's gonna be sorted. So you don't have to throw it into an array and then sort it afterwards. It's already gonna be sorted whenever you put it into the array. So we did DFS, put everything in the array. It's sorted already. Now we're gonna find the minimum, and the way we did that was we started at the first two elements of the array, and then we get the difference of that. We add it into the minimum variable, and you keep moving. You keep moving to the next ones, and then you count the difference. You shift over one more, and then you keep going, and if it turns out there's another minimum that's lower than the current minimum that was there, then that means you change it. And we started off our value as -1 because there will never be a -1 in the tree, and because you can't initialize 0 and say if count is less than minimum, because nothing's ever going to be less than 0, so this is always going to be 0. So that's why you need to start off with -1, and then we just put it right here. If it's -1, then always change it. So that's basically the solution there. It was one of the best, it says.
It was up there. It was
I
up
don't
there.
know if we trust LeetCode like that, but let's see what the complexity is. We gotta subscribe to see it. All right. Well, I guess we ain't checking that out. I guess we'll just do it ourselves. What is it?
It's
Oven.
that's
we loop
Oven.
again.
Yeah, Oven. I would say Oven.
Oven.
Hmm?
Oven, everyone. So
Oven.
we're gonna go into our What are you thinking? You're thinking you ready to?
I think so, my guy. I
Okay.
think so. Not
The
lie,
wool-
my mom is
up?
making some egg and chorizo right now.
Oh, hey.
So.
If I was in your position, I would have already been gone.
Yeah.
But all right, let's go into the outro.
Yes.
All right, everyone.
Sorry, sir.
We're gonna call it there. It's raining over here.
Oh, really?
Yeah.
Damn.
We had a good stream. It was about 2 hours long.
Yes,
We got some
sir.
good problems done. Very good problems that
They were painful ones.
They're painful.
Oh my god.
What happened?
Oh my god. I closed my camera. Oh no. Oh my god. No. Let me send you the link again.
Oh.
I closed my camera by
No,
accident.
that's okay. That's all good. We're about to end right now.
Alright,
there you are.
I'm there?
Yeah.
Alright, let me change my Alright, there you go.
Okay.
There you go. Alright, green screen for now.
Yeah.
Green screen for now. Sorry.
Good stream, good solid stream. We're gonna stream again next week. We had some good problems. I think that's about it. We got this new little look. I got the sub goal right there. We still got the Discord. Hopefully there's gonna be more videos out. As if you saw the videos that have been posted, those are the ones from our last stream. So if you don't make it to the streams, you can just watch those or not watch anything. That's up to you.
Yes, sir. Yes, sir.
Jose, you can end it off, man. That's all I had.
I
appreciate everyone for coming, of course.
Of course.
Everyone that likes, everyone that comments, we appreciate everything. That's all I gotta say.
Thank you guys for coming in, for tuning in for another stream, for bearing with us, for bearing with our hard heads, right? Well, my hard head, right? Where we crash, ideas and stuff. But hey, probably the good thing is that we learn new things, we learn new approaches every day. We get better, right? And I appreciate everybody that comes into the stream. I know we had some familiar faces: Orcus, Codis, Michael, John, Ali, and Kyra. Thank you for the stream. Thank you for coming in, for tuning in, for spending another 2 hours of your lifetime with us, helping us achieve this. And hey, Carlos, though. Carlos is the one doing all this stuff, right? All this fancy stuff. So, hey, props to him. So, thank you guys for coming in, for tuning in. And I hope you guys have a wonderful day, night, evening, morning, wherever you guys time it is. You're looking at this or time it is at your place. But hey, just have a great day. That's the thing. So, that's all for me. I don't know about you, Curtis.
That's all for me. We'll see y'all next week. Join
Yes,
the
sir.
Discord if you want to
Yes,
just chat with
sir.
us and do whatever.
Yes,
Look out for the
sir.
videos, notifications on, all that